Thank you everyone for joining today. Sterling and I will be going through Git and GitHub, what they are and how to use them. So I say through this this tutorial demonstration, if you have any questions, please go ahead and post them in the chat. And I'd say to any moderators, if you feel like something needs to be addressed in real time, feel free to ping me and I'll try and address the question in real time. Otherwise, if we have any time left over at the end, I will just open it up to broader questions from everyone. Okay, so why are we covering Git and GitHub in this hack week? Well, a big part of this hack week is trying to bring the community together, which hasn't been done in any extensive fashion before. And it's kind of because we all kind of, as you can tell during the social hour, we're all kind of self-taught when it comes to coding. And so we tend to learn it because we have to do it for our research. And so we end up developing for our research to get the project done, and then we move on. One of our goals here is to change that mindset a little bit. And instead of just coding for yourself, we want to start coding for the community as a whole. That has a lot of benefits because it reduces code duplication. It decreases the time to get your task done because you can now go off and find another package that already does what you're looking for. But in order for that to be successful in this community, we need members of the community need to know how to work with collaborating tools like Git and GitHub. And so that's why we want to do this presentation. So for those people that are kind of self-taught and are very unfamiliar with these things, we wanted to kind of give a tutorial on them. I mean, myself personally, it was kind of hard to wrap my brain around both these topics when I first started doing them. So it would have been nice when, at least for me, it would have been nice when I was learning these to have someone to kind of give me a few pointers as we're going on. So I'm hoping that this tutorial demonstration kind of does that. Okay, let's see. Okay, so what is Git? Git is a open source versioning control system. So what is version control? Version control is a way of tracking and recording changes to, in this case, as it pertains to us, code. You can also be associated with writing a paper or something like that. And I'm sure we've all done this in the kind of unsophisticated way where you just, you write your final and then you turn it in and you get revisions and you copy it and you rename it and you do this all over the time, all over the place. And then you come back, you have a bazillion files in your folder, all with different names and all with different meanings to all of those names and whatnot. So instead of doing it this kind of brute force way, Git itself kind of gives us a more sophisticated programmatic way of doing this. So basically, the idea is you have this kind of working line, and what you do is you can make changes, and then you can commit these changes, and that commit or that change gets us recorded in time. And so Git kind of keeps track of all this for you. And this has a benefit, like I said, it keeps record of all your changes, allows people to asynchronously work on the same document, because then you can always bring two changes together and handle any kind of conflicts associated with it. And so this is kind of the principle of us being able to collaborate together, because there's going to be simultaneous people working on the same code base, and you need some way of handling these changes. And Git and GitHub too allows us to be able to do this. Now, Git is just the most common version control software out there. There are other alternatives such as Subversion, Miracle, but I'm not going to cover those in this talk. So Git, like I said, is open source. If your computer does not automatically come with it, then the Git website provides has a download site where you can directly Git for your computer. I think I run on a Mac, so I ended up getting my version of Git just by installing Xcode, which is Apple's development kit. You can download Git directly from their website for Windows, and then you can get it with a lot of the package managers for Linux. Now, I also linked to this page on our installation page on the Hack Week website. All right, so some terminology. I already kind of foreshadowed this a little bit. So the idea is you'll hear me say repo a lot. This is short for repository. This is kind of that folder that has the collection of all the stuff you're working on, plus all of Git's internal configuration and tracking associated with it. So that's generally what's meant by a repo. A branch is a line of work you're doing. So often when you get to GitHub, you'll see that the main branch is often named main or master. So this is the current branch that everyone is kind of working and merging changes into. So this is always going to be the most up-to-date branch. Even say like for Plasma Pi, we'll create releases every few months, and that release is always going to be a little behind the main branch because you release and then you continue developing on the main branch. Now, a commit, as I said this before, is where you actually you make a change and then you commit it. So that's basically you're logging it into that history of changes. So in this case, say if I wanted to add an idea, I have an idea and I want to play around with it and then bring it into the main, what I end up doing is I make a new branch, okay, and I start playing around. So each of these little dots is a new commit. So I make changes, make little commits, and then at the same time, other people can be merging in and making commits to the main. And then once I'm all done with this, I can go, okay, this looks good now, and I can merge it back into the main branch. So this is generally a good practice. You very rarely want to be working directly on your main branch. You always want to be playing with your ideas on a separate branch. So if you scrap them, you don't have to kind of backtrack on your main branch. So that's kind of what you see here. I have an idea B, but I never merged this one. This was something I was working on. It could either stall out or I can continue working on it until it comes to fruition. Okay, so Git itself is it's a tool that is done through the command line interface. And so we'll kind of demonstrate both these approaches. So I'll hand it off in a second to Sterling, where he'll go through and show you how to use Git through the command line interface. Now, I get a lot of flack for this. I've never been someone who's good with the command line interface. I always joke if I ever had a superhero power, and it would be my ability to forget. So as a result, I really like the GUI approach. I remember patterns a lot better than I do commands. And so a lot of development environments such as PyCharm, VS Code, spiders, and so forth actually have Git integrated into their IDE. So that, I mean, you're still using Git behind the scenes, but they give you a graphical user interface to interact with it. So after Sterling goes through the command line interface approach, I'll then go through the IDE approach so you can get a taste of both. So in that case, I will hand it off to Sterling at the moment. So I will stop my screen share and hand off.
Hey, Eric, can you take one clarifying question?
Yes.
Oh, well, I guess maybe Dominic already answered it. We had one comment that if you're in your slide 5, let's say you're working on idea B and A, and so you've merged A back in, then what happens when you merge idea B back in? Does it overwrite the idea A improvements, or what happens?
So Sterling, I'm going to take back the screen real quick. All right, can everyone see my slides? Did I share the right one?
Yeah, what would happen if you merged idea B after you did A?
If you merge idea B after idea A, it depends on how you manage it. So if idea B never touched the same lines of code as idea A, it'll just get merged in because they don't have any conflicts with each other. Now, if idea A and idea B do touch the same parts of code, you'll have to go through what's called a merge conflict. So before you can successfully merge the code, you'll be prompted like, you got problems here. Which version do you want to take? And so you resolve those. Now, when you're working on the GitHub side, this will generally be done through code review. Your reviewer will point this out to you before the code actually gets merged. Let's see if I can work in a merge conflict later on in the demonstration.
Can I ask real quick?
Yeah.
It seems like my understanding is that best practice is in the case of B, you want to pull from the main branch into B first. Now, maybe you're going to do this more.
Yes.
So then you kind of, you deal with the conflict away from the main branch, right? So you don't hose your main branch, you deal with the conflict on B. So it's kind of like you merge from main to B, and then it's easier to merge B back to the main.
Exactly. It's best to try and resolve that conflict in idea A or idea B in this case. So yes, you're correct. You would take your main branch, you would merge it into your idea B branch first, resolve all the conflicts, which then will allow you to merge it back into your main branch. That is correct.
Okay, thanks. Follow up, how often does that happen, and how often, like in Plasma Pi, do you deal with merge commits coming into main?
All the time. Every single pull request is a merge commit. So generally, if we have a new contributor, since we are owners of the repository, and when you open up a pull request, we're allowed to write to your own work. And so if you're a new contributor that's not familiar with it, we'll often update your branch and resolve the merge conflicts for you ahead of time. Or we can walk you through the process of doing it.
Okay, thank you.
Mm-hmm. All right, take it away, Sterling.
Okay. All right, so what I have here is just a terminal, and I'm just sitting in my home directory. And so I want to make some new directory. I mean, we're starting from scratch here. So this is going to be my hello world code. Okay. So then I'm going to cd to that hello world. I'm going to make sure that I have Git somewhere in my path. Oh, good.
Sterling, sorry to interrupt. Can you make the font slightly bigger? It's
Ooh. That's an excellent question.
If you do Command plus, it should make it bigger.
yeah.
Well, it depends on the terminal.
It does, yes.
Yeah.
Oh, I guess not. Okay, that's good.
No, I mean, we can be agile here.
Taking advantage of this slight break. Erik, can I get co-host back because I had to restart?
Yes.
Thank
yes.
you.
Excellent. So thank you, Ramis. So let's see, we're going to go into hello world. And then, so we have our folder here, and we're going to be developing in this folder. So Git has a command to say, hey, I want to make this a Git repository. So we're going to type Git Init. Okay. So it said, hey, I'm going to use master as the name for the initial branch. That's okay. And there's some other. So whenever Git gives you output, you should read it. It's worthwhile to read it. Do an ls here. So we don't have anything in our directory, but we can see if we do ls-a, there's this new .git directory, and that is where Git stores everything that it knows about this repository. And we can also, we have a command here, git status, and that will tell us, what is the status of our repository. So it says we're on this branch master. We've not committed anything yet, and there's nothing to commit. So, so now we're going to create a file, hello world. Python. So now I'm going to edit this file. All right. And this is a very simple Python command that I'm going to type. Print hello world. This is to the basics, right? So then I'm using VI as my editor, and I had to type I to insert, and then I'm going to press escape to exit editing mode, press :WQ. Okay. So I happen to have Python in my path, so let's see if it worked. Python hello world. Yay. Okay. Now let's see what Git thinks. So Git thinks that we type Git status and see what it thinks. Okay. Again, we're still on branch master. There's no commits yet. Now it says, oh, I have this untracked file, hello world. And it gave me a hint here. It says use git add file to include in what will be committed. Okay, that's good. So let me do git add hello world.py. And so so git status at the command line is the secret to everything, because it will tell you where you are, what you've changed, et cetera, et cetera. So it says our changes to be committed includes some new file, hello world. So, and it tells us if we didn't really want to track, use there to stop tracking it, but we want to track it. So we're going to then tell it to commit our change. So we're going to do git commit. And because I didn't set an editor, then it pulls up VI as the default editor. So again, I press I to start inserting some text, and I'm going to say added. There's a secret to know what to put in the git commit message. And the phrase that you complete is, if I apply the changes of this commit, it will blank. Okay, so this will add the hello world.py file. I'm going to press escape. I'm going to press :WQ to write my changes and quit VI. Okay, so then that spit us out some information. So whenever you commit, afterwards it tells you what branch you were on, and it has a hash to keep track of your changes. And then it has the top line of the description. It tells us, what file, how many files changed and how they changed. And so the main point of this commit was that it created this new file. So if we do ls, we can see our hello world. And if we do ls-a, there's still that .git directory where Git is keeping track of things. So now if we want to see what did we do in the past, then we have the log command. So if I type git log, then this is going to say, okay, so the changes of your last commit marked by this 40-digit alphanumeric, well, hexadecimal hash. It was created by Sterling Smith, and there's my email address on a particular date, and I added the hello world.py file as the commit message. Well, I'd like to make a change to my hello world file. So go back into VI. So I printed hello world, but that's all nice and dandy. I really want to do it lots of times because I want to say hello to all of the world. So I'm going to print it 100 times. Okay, so for I in range 100, print hello world, and then close out of there. Oh, 100's a lot. So man, I'm not sure if that's really the change I want to make. But so let me see what change I made. So you can type Git Diff, and Git will do a diff across all of your files that are being tracked. So when we type Git Diff, it tells us the path of the file that it's comparing, and tells us the path again here, tells us what changed. And we can see that we got rid of one line of the print hello world, and we instead added 2 lines for I in range 100, print hello world. Now in the Python world, indentation is everything. So you really don't care about white space. So there's an extra flag for git diff, which is -w. And that says, don't tell me about the white space changes. I just know, maybe I had to indent things to insert a new if statement or a new for block. So if you do git diff -w, then it only shows us, oh yes, that's really the change I made. And having tested it and looked at the diff, I say, no, that's not really the change I want to make. I'm only going to change it to 10. So, okay, Ryan range 10. And write that change, test it. Excellent. Okay, that's reasonable. I'm saying hello to the world and not overwhelming my screen. So, so now git diff, excellent. Git status says we've modified this file. So we have 2 options. We can do git add and then the file to update what will be committed, or we can type git restore to discard the changes in the working directory. So I'm happy with where it is now. So I do git add hello world.py. And then git commit. Okay. So if I apply this commit, it will print 10 times. And then we can type git log again to see all of these different changes. So when we type git log, it starts at the oldest, is the bottommost commit, and then can print up to the newest. We only have 2 commits here in our repository, so it only shows 2. Git log also accepts a numerical argument if you only want to see 1, or perhaps you want to see just on 1 line what you've been doing. So git log --1 line. And so again, we have the hash associated with each commit. Also, it's been showing us where our head is. So head is where we're sitting currently. And we can see that it's also pointing to master. So I think at this point, I'll hand it back to Erik, because I think we want to connect this back to the rest of the world. And so he's going to go through similar steps on the IDE side, and then we'll connect via GitHub.
All right, thank you, Sterling. Yes, I will take over and I will do a very similar approach, but through an IDE side. So like I said, there's many types of IDEs out there that have Git integrated into them. The one I predominantly use is PyCharm. It has a free community version, it has a free educational version, and a paid for professional version. So this is just my preferred editor, but whatever I talk about here, there'll be similar steps in other editors as well. So I want to start off by creating a new project. So I'll go ahead and I create a new project. This one's going to be a Python project. It's going to start off as a the Python interpreter will be 3.7. And so I'm going to create this. I already have a Hack Week folder on my desktop, but I'm going to create a new repository and call it Hack Demo in this case. So I'll create this. All right, and this will create that folder for me. So, 1 second. So we can see if I go to my desktop, you got the Hack Week, and now I have the Hack Demo. Now, when I created this, you can see that the ID automatically put in this .id folder. So that's the settings folder for PyCharm. Now, right off the bat, Git is not enabled. So you need to enable it. It's simply done by just doing enable version control, and then you choose what you want. So in this case, we're going to do Git. So now it's setting up Git. And so you can see here's the folder tree that now this Git folder has appeared. So that's where all of Git's logging and stuff is going to be located. Now there was a question in the chat earlier, if there were already files in that directory, will they automatically show up when I initiate it? Now, in this case, the ID PyCharm created a .id folder before I enabled Git. So what will happen is if I go to say commit in this case, it will automatically show I now have all these files and folders that were here. These were created by PyCharm ahead of time, and they were sitting there. Now, in reality, these are settings that are specific to my environment. So I don't want those to be a part of Git, especially if I'm going to be contributing to a open source project. So one thing you can do is you can create a file called .git ignore. So I'll do file .git ignore, and in here I can list. So now I'm gonna, this is asking me to add it to Git's knowledge basically. So this is the same thing as when Sterling did git add. So I'm adding this to be part of the version control, and in here I'm going to say I don't want you to version control the .idea folder. Okay, so if I go to a commit, you'll see that that stuff doesn't exist anymore. Only the .git ignore exists. So I'm going to go, okay, so my commit message in this case, I'm going to say add .git ignore. Okay, so that's what I'm going to do. And then I'm going to commit that. Okay. Now I didn't mention, but right now I'm sitting on the master branch. You can see that down here in this bottom right-hand corner. So I'm sitting in the master branch. Okay. So, 1 second. All right. So what I want to do now, let's say I have.
Oh, Erik, could you increase the font size?
Yes. I think I have to do this per. Don't know why. There. All right. So so now I have my master branch set up. But now let's say I have an idea. I want to do something very similar to Sterling. I want to create a file that says hello. But I don't want to work on the master branch. I want to do this on an ID branch. So what I do is I go, I can do new branch. Okay, so I do a new branch. I'm going to call this say hello. Okay, so I'm creating this new branch. I know, I'm sorry it's hard to see, but now down the bottom it says that I'm in that I am now in the say hello branch. You can also tell that because it has this little kind of tag next to the name. So I'm sitting in the hello branch. Okay. So in this case, what I'm going to do is I'm going to create a new Python file, a new file. I'm just going to call this hello.py. Okay. I'm going to add this as part of the version control. I have not committed it yet, but now Git knows to track it. So I'm going to define a function in this case to say, hello. Sorry. Is that a good font size?
Yeah, looks good.
Okay. So I'm using a fancy thing called an F string here. This is unique to Python. I don't remember which version of Python it was introduced in. But basically what this does is it automatically does the formatting for you. It knows that whatever argument I have named will automatically be converted into a string and placed within this greater string, okay? So this is great. So let me commit this. Okay, so I'm gonna go define function, say hello. Okay, so I'm gonna commit that. All right, that's great. Okay, now let's say what happens if I run this script. So I'm gonna do Python 3 -m. So the -m just tells Python to run whatever I'm about the file I'm about to say as a script. So if I say hello, oh, sorry, the script is hello. Okay. Nothing happens. And that's because as of right now, all I've done is defined a function. Okay, so there's a little bit of magic we can do. You can do if name equals main.
Could you up the terminal font a little?
You want the
Terminal font. if you
terminal
can.
font? How's that?
Awesome, thank you.
Yes. Okay. Say hello. And let's say I want to say hi to the awesome people of the hack week. Okay. Okay, so now what happens? So if I run this, hi, awesome people of the hack week. Okay, cool. So what this is doing here, this is basically saying that if I'm running this file as a script, do what's in here. Okay. The nice thing about doing it this way is this will run as a script and you can still use this function in other places. So I'm like, okay, so let's commit this. Okay, let hello.py run as a script. Okay. Okay, so now I got these changes. Okay, so but we had a previous question where you were wondering what happens if we have a merge conflict. So what I'm gonna do is I'm gonna go back to the main branch, okay? And so I'm going to check out the main branch. So I'm switching branches now. So I haven't lost any of the work on the other branch. I have just now switched to this master branch and I'm going to work here instead. Okay, so I want to create something that I know is going to conflict. So let's just say I'm going to create a hello.py file here. So I'm creating a file independently in master that I have already created in the idea A branch in this case. Okay, I'm just going to say this is a start to the hello file. Okay, so I'm gonna commit
Size
this.
again.
Sorry, I'll try to remember to keep doing this. All right. All right, so I'm going to commit this. Okay. So start hello.py. Okay. So I'm going to commit that. So now I've made a change on the master that doesn't exist in the previous branch. Okay. So before I merge the previous branch and the master, I want to handle this conflict that I've now created. So I'm going to go back to the hello branch and I check that out. Okay. And so what I'm going to do is, this is very similar to, so what I'm going to do is I'm going to look at these two now. So now what I'm going to do is I'm going to compare these two branches. Okay, I'm going to look at the difference of them, and it's showing me that I have something that there's one commit in master that I don't have in my current working branch. Okay, so what happens if I go ahead and try and merge? So I'm going to say, I'm going to go to master, and I want to merge this into my current branch is what I'm going to try and do. Okay, so if I do that, now it pops up, oh, there's a conflict here that I have to resolve. So I like this approach in handling conflicts, because what it's showing me is what I currently have, and then what I'm trying to merge in, and then in the middle is me trying to resolve what's happening. Okay, so let's say, okay, let's say I do want both of these. Let's say I just want both of them. So I can just put both of them in there if I wanted to. Okay, and then I could go, if I don't want this comment because it's no longer applicable, I can get rid of it. I'm like, okay, so this is what I want. I'm going to apply these changes. So now I have properly handled the conflict, but I handle the conflict in the working branch, not the main master branch. Okay. So now let's say I want to merge this hello branch or this idea branch into master. So I'm going to go back to master in this case. So I'm going to check out master. Okay. And so now I want to merge in hello. So I'm going to go, so I'm in master right now, but I want to merge hello into my master branch. So I'm merging it into my current branch. Okay. So I do that. Since I've already handled the merge conflicts, it just does it for me. So now I have this in my master branch. If I want to, I can go ahead and delete the old branch, or I can leave it in place. You can also look at the log, the history of all my changes. So I don't know if I can sorry, I apologize. I can't make this itself a little bigger, but each of these lines here represents a different commit. And in this case, the master branch is kind of this green one. And then, oh, sorry, the main line that I'm working on is this green one. And here's the start hello that I had made on master before I merged in the rest. Okay, so that said, I'll take a couple questions before I move on to GitHub, if there are any.
Mostly handled.
Mostly handled. Okay, awesome. All right, so what is GitHub? GitHub is a code hosting platform for version control. So it basically takes everything we just did in Git, puts it up in a cloud form, which allows us to take all of our local work and then create a place where we can start merging all of our local work with other people's local work. So it allows us to kind of, it's a platform that allows us to collaborate with each other. Okay, so I know usually when I discuss this topic with people, it's hard to map everything out. So I wanted to create this little cartoon here. So in this case, I'm just using the Plasma Pi repository as an example, but this is applicable for any kind of project on GitHub. So let's say I want to work on Plasma Pi. Plasma Pi has its own repo up on GitHub. Okay. And so if I want to start working on it, what I do is I actually make a copy of this. This is called forking. So I fork a copy over into my own account. So all this is still sitting up on GitHub. And then if I ever want to make a change, if I do some work over on my GitHub account and I want to merge it, or want to put it into the Plasma Pi account, you do that through a process called a pull request. So this is basically going, I made changes. I want you guys to include it in Plasma Pi. So you open this kind of ticket up So then the maintainers of Plasma Pi can review it and then improve it and merge it. So that's what it looks like up in GitHub. So to connect that to your local stuff, which is what I was just showing you, what you do is you make a clone of this. So you make a copy of this. You connect your local repository, which I'll show you how to do, up with Plasma Pi. So these two are now connected to each other. So then what happens is if there's a change up on your fork, in this case, you can pull those changes back down to your local repo. Or if you made changes at your local repo, you can push those changes back up to your GitHub account. And so that's how you go back and forth. You do a little bit of work locally and you push it up. Or if someone makes a little changes on GitHub, you can pull those changes back down locally. Now, you're not restricted to just connecting a remote to your own fork in this case. You can actually connect remotes to other repos as well. So I can make a connection back up to the Plasma Pi repo as well. And in this case, you can generally pull changes from there as well. But a lot of repos out there, they have restrictions on who can write to it. So while you can pull changes from Plasma Pi locally, you generally can't push up. You can only push up to your own account. Okay. All right. Any questions? All right. Okay. So I'm going to take this time to do a little bit of walk around GitHub. And then after that, I'll go into kind of the mechanics of working with GitHub and combining your local repository into that. Okay. So let's go to, I'm going to start off using the Plasma Pi GitHub account. So Plasma Pi is an organization on GitHub. So this is very similar to your personal account with a few additional features. So the landing page, you have all the repositories that are inside the Plasma organization. So you got your main Plasma Pi package. This is our website. The Plasma Hack Week is actually the website for the Hack Week. And there's a lot of other repositories going on. You have people that are associated with the organization, and then you can also have teams associated with certain aspects of the organization. Okay, so if we go to the Plasma Pi repository, okay, I'm going to focus on these three main tabs here. So the first tab we come to is your code. So this is the entire code base. This is what Plasma Pi is in this case. And it will generally it will display the README, which is kind of a brief synopsis of the package and gives you links to go to other places like the documentation or the website itself. Okay, and these things here are called badges that give you extra information on what's happening, tells you what Python version that is supported, things like that. Okay. Now, here on the main page, you can also look at the branches that have been created. So we have several branches. You can see here, these are what you see down here are all the, sorry, I think that'd be better. These are all the branches for the past versions we've released, whereas main is the current development branch. Okay. You can also look at all the past commits. So this is just like what I was doing in my local repo. So these are a mark for every single commit to the main branch. So this is the development history of the branch. So if you want to go back and look at something, you can go back and specifically look at what the repository looked like at this time, or what was changed in this commit. Okay. The next thing are issues. So issues is a place of tickets. This is where people can bring up a feature request for the package, or bring up a bug. Like if they find a bug, they can post a bug here and things like that. So this is where we kind of talk about the things we want to add. You're not actually doing any code in this section. This is basically like a ticket to discuss what needs to be done. So you can see Nick has recently made an issue in this case where we have the formulary function gyro frequency, which is particle agnostic, but a lot of the documentation is talking about it as being only applicable to ion. So he posted this issue, goes, we want to make this change. And so it will sit here, and these are freely open for people to grab. Now, during the social hour, there was a comment about how do you know how to pick a topic or pick something to work on that won't take long or will take a long time. One thing that generally happens in GitHub is there's this good first contribution label. So people can look at these to get a list of what the maintainers think are good contributions. So these are things that are open that you can go look at and you go, okay, I think I can tackle that, and go ahead and tackle it. Most repositories do this. We do additional thing where we have available projects. We're always trying to be better about this, but we're trying to create issues that outline different level projects in complexity. So if you want to say a level 2 project, you can click on that and it'll list out level 2 projects for you. Okay. This is unique to Plasma Pi, but every repository does something along these lines of a good first contribution or something like that. Pull requests, this is where most of the work happens. This is where you've made changes and you want to add it to the code base. So this is where you go, you open up a pull request that says, I want to add this code to your code base. So when you do that, so like this is one that I've been working on. I started a while ago. What happens, you open this up, okay, and it starts this conversation. So this conversation lets users talk back and forth about what's going on and outlines all the changes you want to make. And it shows all the files that are being changed. Okay, and so this is where the review actually happens. And let's say like, what would be something that's good to, sorry, none of this is good to play with. Let's say I don't like how this title looks. I can actually create a review here, and I go, the Sphinx extension package for Plasma Pi, I don't know, and more. Okay, so I can make a review. I'm like, I can go, I want you to change this, and so this is where you do code review, and you go back and forth, discussing the code and how you want things to be changed or approved. All right. Any additional questions at this moment?
There's starting to be a discussion on large GitHub repos versus a bunch of smaller GitHub repos, but that's I think it's best if we take that to Discord later on, because this is going to be complex.
Yeah, I agree. Let's do that at if we have time at the end, we can discuss that. Okay, so what I'm going to do is I'm going to go through the process of, like I showed earlier, I'm going to do the process of, I'm going to start with a repository in Plasma Pi, and I'm going to fork it over to my account and link it up to a local repo. All right, so in this case, I'm going to go back to the Plasma Pi organization, and I'm going to actually create a new repo here. And I'm going to go new repo. I'm going to make this a public repo. I want to add an README file, and I'm going to call this hack week, if I can spell, hack week 2021 demo repo. Okay, so this will create a new repository in our account. So I'm going to create the repository. Okay, So now I've just created a blank repository. The only thing that sits in here is a README file. Okay. So now I want to fork this over to my own account. So all you have to do is you come up here, hit fork. And I go, okay, I want to add this to my personal account. All right, done. And now it shows you I have this is now sitting in my personal account. This Hack Week demo repo is sitting in my personal account. And it's showing me that I had forked this from the Placid Pi repo. All right. So that's how you copy repositories in GitHub. You can do this for any repository in GitHub. All right, so now I want to bring it down to my local machine. So what I've done ahead of time, I've actually set up my IDE. So it has my development environment here. So it's linked to my GitHub account. So now it knows it's talking to GitHub. So almost all IDEs have this. So you can see here, this is where you can just add your account to it. Okay. So what I'm going to do is I'm going to go, I want to clone. So in this language, what I'm doing is I'm cloning the repo I have in GitHub. So I'm going to hit clone and I'm going to go, okay, what do I want? In this case, I want the Hack Week demo. Now you can see I also have this Plasma one here, this one here as well. This is because I've already linked Plasma Pi to my environment here, but I want to specifically do the one on my personal account. So I go ahead and I want to make sure that I'm putting it in the right spot. So I'm going to change the directory. Desktop, Hack Week, open. I want to name this the Hack Week 2021 demo repo. Okay, so now I'm going to clone it. So now what it's doing is it is copying the repository up there and bringing it down to my local machine. So now if we go back to the file directory, you can see now I have the Hack Week demo in here along with the hack demo that I just did a little earlier. Okay, so I'm going to do something very similar here. So I've cloned it. And so now I want to do the same thing I did before. So I'm going to create close this old one and I'm going to I don't know why it's behaving like that. That's weird. I apologize, guys. I don't know why this editor is acting funky right now. Okay, so I'm going to start a new branch from the main branch. Okay, so I'm going to go say add hello like before. Okay. Okay, I apologize, guys. I don't know why this is freaking out. Let me log out real quick. And that's the first time that's ever happened to me with this editor. There we go. All right, so
having to close and open things is a natural part of the programming process. So this fits in.
All righty, so I'm going to do the same thing as before. Okay, so I'm going to create. So I've already created the branch, and I call this Hello World. So I'm going to add to this a new Python file, new file. I'm going to call it hello.py. Okay. I'm going to set up the same thing as I did before. Define, say, hello, name, print, hi, whoever I want to say hi to. Okay. All right, so if name equals main, I want to say hello. Awesome people of the week. What I want to do, yep.
Just saying font size.
Oh, I apologize.
Sorry.
Okay. No, thank you for the reminder. All right, I want to do something a little fancier in this case. Let's say, so as I showed before, you run this script by just doing Python -m hello, and this will execute the print statement. But let's say I want to be able to programmatically say hi to different people. So what I can do is I could import sys, which is a default built-in package for Python. What I'm going to do is I'm going to go if sys.argv, if the length of sys.argv is greater than 1, okay, I'm going to go name equals sys.argv, the second one in the list. If not, I'm going to do name equals my default expression. Okay, so now what is sysarcd? So whenever I run Python -m as a script, everything after this is what sysarcd is. So each argument gets added to this list. So what you see here, Python -m hello, in this case, sysarcd of 0 would be hello. What comes after that would be index 1. So if I run this as normal, okay, it says what the default is, but I can also just say hi to Sterling. And of course, it doesn't work. Okay, wow.
You have to run hello Sterling. You forgot the module name.
Oh, thank you, thank you.
You put the
Come on.
argument without the
Oh,
you got it
sorry.
as-
In my notes, I have it as main. That's why. Hello. There you go. And it still doesn't work.
Say hello name.
That should not be required. Just argv name.
No, your last statement.
Oh, thank you. Thank you, Steve. Downside of live demos. There you go. Hi, Sterling. All right, so now, but what I'm going to do now, I'm going to specifically make an error in this. So I'm going to actually misspell argv. So I know this is an error. I'm doing this so Sterling will have something to review and correct me on. So I'm like, okay, so I'm going to commit this. I'm going to say add hello. Okay, so I'm committing this to, so now I'm committing this locally to my add hello branch. Okay, so the next thing I want to do is push this up to GitHub. So now what I do is I push. Okay, so I'm setting this to, okay, before I do that, I'm going to talk about remotes real quick. Like I said, I clone this from my GitHub account. So that GitHub account is named as a remote. Manage remotes. Okay, there we go. So as of right now, so this is the remotes that I have on my local GitHub repository. And so the name of my remote is origin, and it's pointing to my personal account. Okay. So when I go ahead and I push this up to GitHub, I can see I'm pushing up to origin, so my GitHub account. And what I'm doing is I'm creating a new branch called add hello. Okay. So I'm going to push that up. Okay. So I push that up. So now if I go back to GitHub and I'm back at my personal account right now, you can, it already says that it says here, add hello had recently been pushed up. So I push it up, and this is the branch that I want merged. So I'm actually gonna, in this case, I'm gonna actually go to that branch. So I'm gonna go to the add hello branch, and I want to contribute this to the Plasma Pi version. So I get that, and so I click that, and I go open pull request. So now I'm starting that pull request. So I go add hello.py. Okay, and go, this defines the say hello function. Okay. So I can create this pull request. So I create the pull request. And so now you can see it has switched me to the Plasma Pi account. So now under pull requests, it has this new pull request. And this signifies to all the maintainers that someone wants to add new code. Okay. This is the new code that I want added. So what I'm going to ask Sterling to review my code. Okay. So now I have purposely put an error in there. So now Sterling can actually comment on that. So Sterling, I'm going to stop my screen share and pass it on to you now.
Sounds great. All right, so I have pulled up here Erik's. It's funny, your username isn't anything like your name. So anyway, you see what he made a pull request here, but it was actually on, not on his, but on the main Plasma Pi. So let me click here. I see his pull request. I would have gotten an email saying, hey, so-and-so requested a review. So I'm going to come here and I can look at this and okay, this is great. So in his description, he says he's defining the say hello function. So let's see, let's go over to the files changed tab and see if his code reflects what he thinks he's changing in the pull request. So, okay, so this is interesting. We import sys. Okay, that's all fine and dandy. Sure, we have say hello. Well, it's good to define a function. That's great. So I agree that you define the function here. Can you add a doc string? All right, and then I'm gonna start a review. So in GitHub, you can click on the plus and drag it to comment on multiple lines at the same time. Okay, and then we have the part down here. Okay, that's good. If name equals main, so I guess we can run this as a script from the command line. Yeah. So there's a special button here in GitHub where we can insert a suggestion. So I just want to make a suggestion on this one line. I must have like superhuman abilities that I can just read Python and notice that he's missing a G there. And I'll say, did you test this? And then so the suggestion, and then when I preview, we can see that it shows the, what change I'm suggesting. So, okay, so we add that, and then, so then up in the upper right-hand corner, I'm gonna finish my review. I'm gonna say at Rocco, this is great to add. Thanks for your contribution. Please see the detailed comments. And I'm gonna request changes to say, hey, you know, that we kind of need to work on a few things here. So I'll submit that review, and then it gets kicked back to Erik. So I'll stop sharing, Erik, and you can.
Awesome. Thank you, Sterling. All right, so back on my side. All right, so yes, typically when this has happened, I would get an email or some kind of notification that Sterling has reviewed my pull request. I'm like, okay, so I see that he wants me to add a doc string. Completely agree. You can see other people have already liked this, Dominic, and so you have all these reactions to it. I'm like, okay, so I tell him totally agree. I'll add this. Okay. And then this one here, okay, yep, yep, you're correct. So what I can do now is I can directly make these changes. I can commit this suggestion directly here. So that's what I'm going to do. So I'm going to commit this. Okay, so now I did that. It made the changes, and you can tell that this comment he made is now resolved. Okay, so if I go back to the repo on my personal account, okay, we can now see there's an additional commit. There is this commit that Sterling has suggested. So now my GitHub repository is ahead of my local repository. Like, okay, so how do I get this back down locally? Because after I do that, I still need to add the doc strings as per Sterling's suggestion. All right, so if I go back, so I'm still sitting in this add hello branch. And so in order to get my local copy to kind of know that there's changes out in the world, what I do is I do git fetch. And so this will go out there and ping all my remotes to see if anything changed. Now, once that happened, it's a little hard to see, but a little blue dot showed up next to my add hello repository. So this is telling me there's a change up on GitHub that I don't have locally. So what I'm going to do now is I'm going to pull those changes down into my local copy. So I'm going to hit this little blue arrow, or you can come up here and you're going to do git update project. This is the same thing as polling. So I'm going to bring that change into my local copy. So I'm going to, okay, I want to merge this into what I have. I click OK, and you'll see this updates to argv. So I'm like, okay, that's great. I did exactly what I wanted. So now, next thing I want to do is add a doc string. So in Python, a doc string is comes right after the function or class definition, and it is surrounded by triple quotes. Okay, so I'm going to say print a hello statement. Print a hello statement to screen. Okay, so as everyone in Plasma Pi knows, I cannot spell. All right, so I'm going to commit this change. I'm like, okay, I'm gonna add docstring. So I'm committing this change. So again, I've just added a docstring, and I'm going to commit that change to my local repository. So I commit that. Now I want to push this back up to GitHub such that that pull request gets updated. So now what I'm going to do is I'm going to push. So that's a little green arrow here, or you can come up and go git push. So I'm pushing my add hello branch up to my origin remote, which is my GitHub remote, to the add hello branch on GitHub. Okay, so I'm going to push that up and push it, and it was successful. So now if I go back to the pull request, let me refresh this, and I go look at file changes, you can see all this has been changed. So the argv has been fixed, and I now added a document. So now it can go through the final review process. So I'm going to hand this back over to Sterling so you can do the final review process.
Actually, Eric, will you request a review again?
Yes, good point, good point. Let me share that back. All right, so share. All right, so now if you come back to the conversation tab, I'll go back up to reviewers. It has this little refresh button. So I can click this to re-request Sterling, and this will then ping him again that I'm ready for a new review. All right, thank you, Sterling.
Okay. So here I am on his pull request, and I got the ping, and so I'm going to end up back on the conversation page and say, oh, hey, that's pretty cool that all these people are watching our repository. And okay, so he said, totally agree, I'll add this. And then GitHub kind of pings me and says, oh, you know, this conversation's outdated. So okay, I'll say, okay, that's fine. And then so somebody was procrastinating. So he requested my review, so I'll click on add your review, and oh good, he got a doc string in here now. Oh, you know, this was supposed to be in a hi, my bad. And so, you know, sometimes you just notice it, and then I don't have permission to push on yours, so you'll just have to accept that yourself.
Okay. Here, so as Sterling is sitting there, so I know he's doing that now. I'm going to do the same thing like I did before with argv. So I can directly, I'm like, okay, I totally see what he's doing. So I can commit this right away. And so now, since I just committed it, he can probably refresh his page. Yeah, see, all right, pops up there.
Okay, well, that's better. So I'm happy with that. So I come over here, click approve, and say, looks great.
And I think maybe since Sterling doesn't have writer privileges, let's be a little agile right now. And Dominic, why don't you share your screen and go ahead and merge this?
Sure, in a sec. Allow me, this would be,
Just don't forget to share your screen.
yes, working on it. There we go. And now we see this pull request here. We've got 2 approving reviews, one actually reasonable and one that was actually too early because I missed the typo. And now we can just hit merge, hit the green button and merge it. And now when we go to code to see the state of the repository, we'll see that here this file was updated a minute ago, and let's double check the contents. Yep, no typo here, a doc string here. That seems to have worked. Nice.
Awesome. Thank you, Sterling and Dominic. So that's the main workflow of getting a pull request merged into some kind of code base. Now, one thing that we left off here that I'm going to make a brief comment on, a lot of packages you work with have things called checks. So this new repository does not have any checks. So there's no kind of testing of new code. There's no checks to make sure that everything's going to work right. So if you're working on larger packages, you'll often see a lot of checks that exist, and these run every single time you push a new commit to your branch. And so like all this yellow or red cross or check mark are telling you the status of those checks. So let's say I go to this one, this pull request, I have a whole bunch of checks that have been run. So every time a new commit is made, several checks are run. So predominantly the CI. So these are running the package's tests on different environments. So in this case, you're seeing is being run on several different versions, or Python 3.7, 3.8, 3.9 environments. And then we have different dependencies. So in this case here, Python 3.8, we're running the tests in Python 3.8 using NumPy's development branch. So that's basically exactly where NumPy is right now, and not just its last release. What's nice about this is we can pinpoint breaks before they ever get merged into the code. And so you have a bunch of checks. So you can do checks based on tests, you can do checks based on documentation, and they all show up in this little box at the bottom of your pull request. Now, if you ever
Erik,
yeah.
so sorry, you have only 4 minutes left.
Yes, 4 minutes?
Uh,
Yes, I'm just wrapping
3
up.
minutes. Okay.
So I would say if you're ever trying to go through a pull request, don't get overwhelmed by checks. Typically, checks will always fail until the very end. It's up to the work between you and the maintainer to get it to the point where checks are passing. And I will often open up pull requests knowing checks will fail, trying to get other things done before I get all the checks to pass. All right, so I'm going to end there.